Uh, hey, welcome to Coffee Compiler Club. This is Cliff, and we're here today to talk about compilers and language runtimes and anything ever to do with typing systems and whether or not you should regex. Um, and I'm late. Yes, some people shake their heads. No, that's my opinion. And I'm late to the meeting because of other unrelated issues, so we're a little shy today. And I have a demo, but I first wanted to introduce Haven and have him spend I haven't checked your audio yet. 30 seconds of who you are and why you're here. Can you?
Yeah, audio check.
Yeah,
Eh,
cool.
Perfect.
Hi everyone, I'm Haven Spencer. This is my first time here on Coffee Compiler Club. I even tweeted about this earlier. I think I've discussed this with Cliff some time back too. I think I'd sent him an email for a previous meet, and it reached him much after the meeting happened. I think there was like a 2 day delay,
Yes.
and I was kind of shocked that happened. I think it got stuck in some gray list somewhere. I think for the first
Well,
email that
wait,
I
wait,
had
wait.
sent.
No. Don't tell us the troubles you had connecting. Why are you here?
Frankly, I'm here because I've been following crafting interpreters from Robert Nystrom. I've started to get deeper into compilers, and I felt this was a great place to get connected. I found this on Twitter first, that these sessions happen, and that's why I wanted to join in and see how it goes. I even see your summaries of things that are discussed, and it's quite interesting topics. So I feel I have something that I can pick up from here.
Cool. Okay. Um, Anyone else want to throw something out before I go into my fairly broken weak demo here? It was really good until last night, and then I fixed something, and that was bad. All right, let's see if I can figure out how to demo. So what I've got, so this is an AA update. I've been working on overloads for the past 6 months. I finally think I have the theory on overloads worked out. They seem to do what I want them to do. And let me see here. If I fixed, I have a small printing bug I need to fix, which I have to go right away to do before I can demo, which I guess I'm still hacking demo before I go. Actually, somebody else want to say something before I claim I have my typos all done here?
You know, I could give a progress update on mini VM. I finally got floating point numbers working. I got F32 and F64. So
I
turns out
would
just
want to hear that. Yeah.
yeah, I just ended up bit casting them, like reinterpret casting them, essentially, not C++, but similar idea, right? From whatever their type is, just fill the rest with zeros if it's larger, and then make them an I64, pass them in the normal registers, and yeah, because I didn't know the type of the result of a call, because MiniVM is a dynamically typed language. It's Lua, and you don't know whether a call returns a number or a string or whatever. So
It kind of seems like you started at the middle.
yeah, basically what I did was I fixed floating point by just pretending it was an integer as a bit representation, and then casting it back when you need to actually do floating point ops. But it turns out most operations on floating point numbers in Lua are like store them to a table. Doesn't matter what kind of type they are. If they're the value, if they're the key, you have to type check them and like do a switch. But other than that, the only operations are like the math operations on floats that differ from ints. Everything else is just like, is the number the same? Then it's fine. And to handle nans, well, you can't store nans as keys in Lua. They trap. And I also got an error type handling. So there's a special type that a function will return if it's an error. And if you have a value of that type, what you do is you return that value. So this is how I throw. I just return all the way up. And it's kind of like an error union, kind of, except it's an everything union because it's dynamically typed. So I just put it in the everything union instead of making a special, like, MiniVM is based on Yasser's tilde backend, and oh, my internet's unstable. And yeah, it's just, it turns into tilde backend, and it works fairly well. There's supposed to be a big update to tilt the backend TV fairly soon, maybe.
Yeah,
So
it's in the works.
yeah, I've heard that for several weeks now.
I
can't wait
am.
for my
How
tail
many?
calls to work
How many days
correctly.
am I in? I think. Let me go check real quick. I think I'm 25 days in. Let me
Yeah,
check.
25 days since I've had my bugs fixed. You fixed one bug.
23. Yeah, 23 days in. And how many commits is that? Some 41 commits. And there have been some fun things in there, some like irrelevant things, and then some nice additions. So the big ones are going to be
Yeah.
I guess progress update for my stuff, back end fun stuff. There is, let's see. I had a list somewhere. Let me go pull it up.
The thing I'm most excited for is tail calls working correctly.
Yeah, there's like an ABI thing to do with
slightly
tail calls.
faster. Yeah, because if you have to like set up, you have to clean up, pass the arguments, and then do a little more cleanup if your arguments were passed a little funny. And it doesn't do that right now. If you have more than 6 arguments to a tail call, it's just like, I'm going to overwrite some things.
So those parameters get passed through the stack, but if the stack gets cleaned up while I'm trying to pass parameters through it, I have to like do the math differently. So there's that piece. And then what else did I fix up? I changed
faster compilation.
So there's that piece, and that came from some of the redos of the CodeGen stuff. I kind of just ripped apart some things that had to do with x86 and said, oh, these are no longer x86 specific. They're just like CodeGen specific. So it's going to be like we can do CodeGen stuff like instruction selection, scheduling, all that good bit, register allocation, without necessarily talking about the target machine. So like I'll just say, I've got some register constraints. The register allocator will deal with that. It puts things on a timeline and sets like use and like def masks on things. And it's like, oh, okay, cool. And so that made it a lot easier to add the new stuff, which was ARM support. So that's been in the works for about 20-ish days as well.
I got 2 questions. First is not a question. Shaw, you said numbers are the same while talking about floats. So that makes me feel uneasy.
What's the uneasy part? What do you feel like could go wrong specifically? Because I have contingency.
But my real question,
because mini VM.
It's how are you calling Yasser's code? Is it like LLVM IR? Is it a library or a C interface?
It is. I build it through a library, so I have a bunch of functions that he provides in his TB and they just build up a sea of nodes IR, and that just turns into x86. I have to call like 3 functions total, that need to, and then I can just build the IR and otherwise than that.
Nice.
It's real simple. It's like you want to add 2 things. You call tb inst add, and then you get the function you want to put it in. The argument 1, the argument 2, is it signed, and I think that's it.
There's like a flags thing about like overflow.
As I do basic block versioning. Anyway, I must be thinking of floats, but maybe I'm not. But floats is 3. It's either 3 or 5 arguments, but it's a very simple IR. It's a very simple IR interface. I don't know how simple the IR is. I can read it though, which is good. There's a disassembler in TB that you can call that it just disassembles your code and gives you a big like buffer of it back, which is nice, or prints it. I can't remember. I think it prints it. I print it. And either way, it TB is called by MiniVM's one of MiniVM's backends. It's only backend, but MiniVM is designed to have multiple backends. Right now, it's just TB is good enough. And now that there's an ARM backend, it has the only thing I'd need really extra is like rounding ops and a WebAssembly backend in TB. But other than that, it does basically everything an interpreter should. The compile times are like 50 to 250 microseconds. Yeah, microseconds. They're incredibly fast. I might just have good RAM or something, but like they're like a hundredth to a 50th of what LLVM would do or GCC JIT. And it's a lot more inspectable. Like you can just if a node is like v3 equals add whatever, right? You can just do node arrow GVN, which stands for something, but it's just 3 because you're
Yeah,
assigning
all the nodes get a global value number, and so that's what GVN stands for.
Yeah. Either way, TB
Oh,
it has much more.
we have a jargon collision.
Ooh.
I use unique node IDs, which is usually UID for unique ID. And I use it for nodes, and I use it for types, and I use it for every other thing on the planet has a unique ID. Fine. GVN I always use for global value numbering, which means it is the algorithm which does global value numbering, not a global value number. Whereas
Yeah, so I sort of, yeah, I've got like a sort of collision there where I will say there's global value numbering, as in we can deduplicate the things when they have the same like inputs and such.
Yeah,
and then
right.
each node is then like sort of tagged with a number.
Right. Yeah, that's the
Yeah.
unique ID. Every node is
Yeah.
tagged with a number. And in
Yeah, I
language
also
Java,
call
you
that
declare them
I
all.
call that the global value number.
Yeah, I got you. I just collision with the algorithm name. That's why I was
Yeah,
like,
yeah.
okay, fine, gotcha. But I use those
Global value numbering
I'm
fixes
sorry.
global value numbers. The global value numbering fixes global value numbers. That's how I see
No,
it.
they're not.
I don't know.
No.
Really?
Global value numbering is like you're structurally the same, so you can be common subexpression, and that means that you hash on the opcode, not his node ID or his unique number, and his inputs by their unique ID. So you have an add, it's input to the left's unique ID, input to the right unique ID, and the self guy is an add, not a unique ID. That's your hash and compare. Whereas the unique ID is just a number, and I use it like bit sets for I'm walking a cyclic graph. You have to have a visit bit or you cycle forever.
I
So
would
I do
agree
bit.
that UID is a better name. I
That
kind
was
of
where I
agree
came
you
with.
there.
I'm using UID for that. That was why that's the
Even
reason I
just
caught that up
ID.
and said, oh, there's an issue here. It's not I mean, you pick your names however you like them. Just pointing out there is a thing to be said there. Oh, no one's tackled the document yet either, and Theodore just showed up. Hey, Theodore, mistakes were made. Sorry for the late start here. If you get a chance, would you put the header and the boilerplate in the meeting doc?
Just a sec.
Thank you.
So far, we talked about TB and Shah's. Actually, Shah should give the title of what he just said.
We talked about mini VM and the new stuff in mini VM, and Yasser talked about, well, he can tell us.
Yeah. Well.
Yeah.
Give him a minute to catch up.
Just some TV stuff and some mini VM stuff, and
Yeah, we had the mini VM and TB progress updates, I guess.
Sure. All right. Well, my demo, it worked because I saved everything back and I rolled backwards to yesterday, the GitHub, So the end of the demo fails because that was what I was fixing, but I know how to fix it. And I was just like, I could beat it down, maybe even while the meeting goes on, but instead I'm just gonna go what I got from yesterday.
We can pretend that the last thing you do works.
That's right. Let me try to share. Just this kind of share. How about this kind of share? This thing. Now that's going to be way too small font. Give me a second to do the font thing. And then the Windows is resized badly because, why not? Somebody come through and tell me that font is readable.
It could
I
be a
can read
little
it
bit.
just fine, but it's a
all
little
right.
small.
Yeah.
A little bigger can be.
A little bigger. Well, I'm
Yeah.
here hacking on font size, so let's go a little bigger here.
Somebody can please share when we roughly start that recording, so we can roughly make the timestamps.
Something like 6 after.
Okay.
How about now? Does that look better?
Yep.
Yep.
Okay. How do I want to do this here, Cliff? It's gonna go. No. How about this one?
I can read everything fine, but I was wondering, can I minimize the
color.
side panel?
Sorry,
on
what?
Zoom? On Zoom, is there a way to minimize the side panel so I can have your screen as my entire screen?
You should be able to say full screen, and then you can go to the gallery, and there's a bunch of gallery options. I don't get it right now because I'm the host. Let's see if
This actually, if you just double click on the shared screen, it goes full screen for you, and then you just, and on the side panel where everyone's name and faces are, you can just there's like a minimize button on top. That's the best view I could figure out to get full screen.
So is that still too big? Should I need to shrink my window? I don't need all this real estate now.
No, it reads fine. I was just curious because I see everyone's faces to the side, and I just want to focus on the demo.
Yeah. Okay. So what I did was I made a simple, strongly typed lambda calculus evaluator, so an SEK machine. And then I wanted to do overload. So I'm going to talk about the SEK machine as a lambda for a short period of time, just so you can see how it goes as a lambda calculus. So I have a program that consists of the number 3, and I run at the bottom, and you get an obvious answer. I'm going to step up pretty fast here, and so you should interrupt me. So here's basic math. Types as an integer, executes to a 7. I need to this split. Let's see if I have my notes in here. I lost my notes because of the great oh, don't tell me I lost my notes. Crap. I had a nice list. Did I lose it? I lost it. Yes, I lost my nice list. All right, we'll have to do a little hunt and peck.
Just wondering, the REPL, do you run the entire program from start to finish every time, or is this like one line at a time evaluation?
I am running the whole program. I tried working a REPL out, and I got it mostly far enough along, and then I realized I had a bunch of canned tests that are more exciting that I wanted to bring up here. Yeah, here we go. That I can step through here. We'll have some extra tests I'm going to skip at some point, but we're fine for now. This guy wants to do this. So what? This is just a function. All right. So the first piece of error mistake on the function is the evaluation shows an extra argument. It shows an AB to the B. The A is an extra argument I'm going to be passing along that contains no information until I get to overloads. So I'm going to show more things for a little bit to show you I have a valid SEK machine. It's a SECD machine. It's a simple SECD machine. People know what that is? Should I talk about what a SECD machine is for a second? It's just a simple type lambda calculus evaluator.
Could you give a ELI 5 for that?
I'm sorry, should I give a what? A link or a?
No, and explain like I'm 5 for that.
It's a roughly based stack execution machine for type lambda calculus. So in my typing system here in my syntax, so here is a function syntax, which consists of a curly brace args to a function body. And here is another version where I've taken that and put it in an evaluation context. So open paren, the first argument has to be a function, the second things and later are arguments, and evaluates it. This can be done on, and the evaluation is sort of straightforward. It just says take the first thing, do the next thing, do the next thing, do the next thing. You evaluate the terms one after another. Think of it's like Lisp or Scheme. I have a Lisp interpreter here, but a very primitive Lisp interpreter.
Got it. Yeah, the other example, I think, where there was that plus 3, 4, that made sense as like a prefix notation.
So as a Lisp interpreter, I'm sorry, let's go. You want to test basic 2. Let me go find this guy. Test basic 1. This guy. Yeah. So plus is a primitive in the language. Plus is a symbol it's looked up. I look up the symbol, it gets a hit because it's a primitive. The primitive tells me it is a function typed that takes 2 ints and returns an int. That's the type of plus. So I can put it in the context, what you just see there, and then evaluate it. I could also just, do this. And then when I evaluate this guy, he says, oh, I'm a function down here at the bottom of the screen here, has my extra argument, which I'll talk about when I get to overloads, takes an int, returns an int. And so the evaluation is a continuation. K1 is a continuation. Continuation consists of a lambda and an environment which is empty. The continuations are all, standard heap allocated continuations, nothing exciting there, exactly what you'd expect out of a standard sort of guy. Here's pair. Does everyone predict what pair will do? Let's do number 5. The .1 is load field number 1 from a pair. I'm trying to skip. Here's a let. This is the most simple version of a let. Let is fully recursive and mutually recursive. So it's a full let rec recursive, mutual, whatever hell you want to call it.
Is the pair the one, is that the first or second?
It's zero based.
Zero base, good.
Yeah, okay. So that was what? Test basic.
There's just one question. In the previous example, where there was just a plus in the program, that
Yeah.
didn't give an error?
No, plus is a valid lookup. I look up plus, I find it in the primitive context. It gives me a function back. The function takes 2 ints and returns an int. So that's a
Right.
perfectly valid program.
But we didn't have any ints to give it.
But that
I was thinking
doesn't
like
I don't have to evaluate it. It's just a function.
Okay, that's neat. Yeah, that doesn't happen. And okay, that's different behavior for me.
Right. That is normal for every Lisp interpreter on the planet.
What he's saying is that function is a value, just like 3 is a value or 4 is a value.
Yeah.
Function itself is a value too.
Think of like other languages where like you could type plus and like write a function called plus like spelled out. It's the same, but in this language, identifiers, well, plus is a valid identifier or function name at least. That's one way to think of it. Like you could totally just write a function that takes 2 arguments and adds them in basically any language, in C even, and call it something. But in this language, plus, just the plus sign, is itself a valid identifier.
That's correct. And it is exactly as if I had said, add is I'm typing in the upper left corner, is a function which takes an X and a Y and returns me the add, however that's done. This is the primitive add. Except that I misspelled add with this. So that's the definition of plus in this language, except I wrote it internally, not as part of the language syntax.
Are you allowed to plus with more than 2 arguments? Like, could you do plus 1, 2, 3?
Well, in this showcase guy, no, but it's sort of trivial to add the 2, right? So it's a full form, SDK machine. I can do all, and then I can hack it any way I like. So I have primitives that do shit. Yeah, fine.
Is there currying? I might have missed that.
I have multiple arguments. You trivially curry by defining a new function to have more arguments predefined. I'll show you a curry in a second here. So here's if tests. On the right is test basic 7, and it's just if is a special form, so it has a funny syntax. It's not a function call, because if it's a function call, you evaluate both arguments. But I want to only evaluate the one argument. And what were you saying, currying? You want a currying example here? Sure.
I was just wondering, even though I never use it.
Yeah, right. So here's add2 is a function which takes an X and calls add, and I'm going to curry plus, which normally takes 2 arguments. And now I have a function that does an add where the first argument is, well, the second argument is always a 2. Fix that. First argument is always a 2. So that's a curried, it's always a one-liner where you just say, curried name is function of fewer arguments, arrow, the thing I want to curry plus the arguments I want for it. So currying is always a trivial one-liner.
So you can build up currying with a one-liner, but it doesn't like you can't just do +1 to get like you can't just do parenthesis +2 to get that same function.
It's not right. I'm not doing syntax. These are all things that I could go do, but it's like that's not the goal here. So here's another function, which just has embedded on the right there, test basic 8, just has an embedded if in it. The function takes the A, which is my one I'm going to ignore until I get there, takes a predicate P, and then returns me int 8 is non-zero integer 8. It's just me having a little typing info. I'm a little smarter than your usual typer. Fine, I think I'm getting close to what I want to do here. Everyone can see this one. I'll run. I'm getting up to the point where we're gonna start getting a little more exciting. So this guy says function is what I just had a second ago, and I'm going to evaluate it on a 0 predicate, which evaluates to a 5 because it's false. And also I'm returning as part of the pair the function itself. So you can see in my evaluation at the bottom there, I have a pair of 5 and a continuation taking the lambda, which has function defined within the environment, and then an empty environment after those. The environments make a stack. Anyhow, is that sort of obvious what's going on there? I see Shaw nodding his head yes, so I have to like assume. Let's see how many of these things I want to go through. Probably not. I think a bunch of these now on the basics. I'm probably done with basics.
Pairs are not heterogeneous. They're like they're like two tuples essentially.
Yes.
Okay.
Let me skip a bunch of these. Here's a string. Guess what? It does what you think it does. No, I lost my list of pre-selected dudes. So now I'm hunting and pecking. What did I just do? 16? Let me look at like 17, 18. That's length. I don't think that's pretty obvious. Here's an error. Mixing basic types. String and int. Can't do that. No one cares. That says whatever. If random, give me the length. Fine. Random is how I mix things up. String concat. Okay, fine. Okay, I think I'm done with basics. So let's look at compositions here. We're gonna get a little weird, and then I want to cut pretty quick to overloads. I'm not too far from overloads here. So all that composition says is G is a function which ignores its first argument and returns a 5. And then I apply this function to itself, which I ignore and return a 5. Done. Okay. Argument of 2 functions that just applies one to the other. Hopefully it's pretty obvious. Here's a more brutal version of the same thing. I'll do it and skip on here. So the evaluation of this is I have a function of 2 arguments, which returns a function of 1 argument, and then applies the 2 functions to the function. These things stack up quick nasty. If you look at the A, B, C's, and D's going on in the answer, you'll see, hang on, somebody just came in. You'll see that the final result is a function. I'm a function of 2 arguments. So let me go over to the typing here. Here's the first argument, not counting my mystery overload. Here's the second function, not counting my mystery overload. And I'm returning a function. And the F here is the same as the result of the second guy, and the D here is the same as the result of the first guy. So a function here which would take a C and makes a D, and the D will make an F, and that's what you get out. Okay. Now I think it's time to start cutting faster forward here. Let me look at 3 for a second. Exciting self-recursive function. I do something sensible, but it's a boring function. I've started faking maps over functions, which all work here. One of these has got a good one, and I should do that one. This is just me running maps over single arguments. I don't have collections yet, so collections will come when I get structures. Do you care for this one? No, it does the same thing. It's an ugly one. It's not going to say anything new. Let me go look at recursive because these do more obvious things. Okay, so here's factorial. Classic factorial. Any questions?
Actually, I had a question. Could you explain that section after the question mark?
Yeah. Okay. So let me go. I fixed these in the other. In my error for the demo, I had all the demo things fixed a little bit. Okay, so factorial is a function. That's what curly braces are. Takes an n, that's your integer, you're going to factorial. If n is 0, I'm going to come down here and return a 1. But if n is not 0, I'm going to do this thing. Okay, what's this thing? Well, this thing says multiply n times the factorial of n minus 1. That's your minus there, so n minus 1. So it just says factorial is a function. This is your classic factorial recursive function definition. Factorial is a function which is, it's either 1 or it's n times factorial of n minus 1.
Right. Yeah, it's just scrambling my brain that I'm seeing it in that prefix notation. It's the signs are not in between the terms.
Yeah, that's because this is.
I'm not really thought of this, so that's just new to me.
Right,
It's nothing else.
This is standard lambda calculus form, not in fixed notation, but prefix notation. If I put the minus here, and I put the multiply here, I won't be lambda calculus notation, and I have to have a fancy parser that understands how to parse infix and how to understand precedence order, which I don't have because my parser sits in like 100 lines or less. And that's the reason you use lambda calculus forms, is because one of the reasons is that the parsing is fucking trivial. Okay, fine.
Right.
Let's go look at factorial being done something exciting with, and I'll come around to factorial a few more times because I'm going to do something with it here. So all I'm doing here with this factorial is I'm executing it, which shows that my SEC engine in fact works here. It's not super fast, so I don't want to get big numbers on my factorial here. But, you know, I can compute 120, 5 factorial is 120. Okay, what is I doing here? That's a cyclic self-reference test case, which we probably don't want to look at. It correctly says I'm going to crash at you. This one is more exciting. This guy, let me do this for a second, see if that helps. What are we up to here? Recur 4. Let's go talk about this guy, and then I'm going to get ugly with him. So here is a generator of counters, and if I evaluate it like this, it has no arguments, so I just wrap it in parens. That evaluates it. It gives me something back. It turns out it gives me a counter back, because the counter is what I get when I call, well, I define increment, and then I call increment on a 0, and it returns me a pair. So executing generator gives me back a pair. The pair consists of the counter itself and a new function which will increment the counter by defining an increment on the counter plus 1. But I just get the counter value back, and that says I have a counter of did I do that right here? No, gen 0 would give me the counter back. And the other guy, so it gives me back a crash, because that's what I do tests for before I do demos. Great. And the other, okay, well, but the more complicated one works. Fine. And then I get the increment back, which is the pair of the count of whatever. Let me look at test recur 5 here. Is that the one that did? Here we go. Yeah, here is where I'm going to show gen actually produces 2 hidden counters. And the reason that this matters is because I have full-fledged closures. I have real closures. Yeah. Okay, I made 2 counters, a counter X and a counter Y. And I call them 0, 1, 2, 3 because I'm trying to keep all prior instances so I can tell that they're all there. And then I increment my counters, and that's get the 1 side of things, which gives me an increment, and then increment counter number X again. So counter X's value is a 2 and counter Y value is a 1. There are actually 2 counters there. And so that's the proof of the SEK machine actually having real closures.
In this code, basically doing .1 is as good as calling next, right? Like how it is in
.1
other
is
languages.
giving me the second half of a pair. So here I have pair, On that line I've highlighted, I have a pair. I made a pair. It's
Right.
two values. I call them either
Right.
dot zero or dot one. This is a structure of two values. This is the first or the second element of the structure.
Right. Okay. Yeah, the first element is the count, and the second is your function to get the next element.
Yes,
in the
exactly. Yes. So all I'm doing is claiming I have an actual SEK machine, which I need to move along. I'm going to throw out structs, and then I'm going to, which will be pretty quick, and I'll be done. So that's a cyclic self-reference. This is, oh, here's Newton's method. That's kind of exciting. Okay, let's do Newton's method, and then I'll move on to structs and be done here. Yeah, Newton's method. So I'm going to solve for Newton's method. I'm going to claim my square root solver takes an x and wants to solve for it. And the guess is itself x, which is horrible for a guess. And then and x is also the thing I want to get. So square root of 16 is 4, and the square root of 38 is 6, roughly, because I'm integer only here. And then you do Newton's method, which is divide of an add of your real value divided by your guess. Add your guess, which, you know, this should be your guess if you got the square root right. You add your guess and you average it, so you divide by 2. If you got an equals, guess is new, I'm done. I declare new, and I got my guess, and I'm out. Otherwise, I have to solve again on the new guess. So it's just Newton's method. I'm not going to go any more detail there. I think I'm done with that guy. Let's look at structures, and then I'll hit overloads. Here's a structure. This is AA syntax for a structure. It's a little weird, but it's not actually very hard. The curly open. Sorry.
What's the @ of sign at the beginning?
What was what?
The first symbol. Just for
At
the
sign.
opening curly.
At sign.
What does that signify?
What is that?
What does it signify?
It signifies the start of a structure definition.
We don't give a name to a structure definition?
No. Structures are anonymous. This is in general true. You're probably used to only seeing structures given names, but you don't have to. I just have a structure, and then I return it as a value when I execute it.
Right. And when we say A is assigned to 1, that's like a default assignment?
No, that is, I'm assigning a field A the value 1.
Okay, and that's immutable. It can't change.
And that's immutable. Yes. This is a pure lambda calculus. It has no side effects. Yes.
Got it.
So the assignment and the default assignment is the only assignment. You only assign it once ever at creation time, and therefore that is the value.
Right.
Okay. Here's an application. That's the outside. That's a function call. Here's the function. The function takes a G, returns me a structure where it has an X and Y field, which are both assigned the value whatever I passed into my function, which happens to be 3. So that just does the obvious thing. And you'll notice my typing knows it's a hard type 3 too. Here I'm going to say temp is assigned a value which is randomly either a structure with an X and a Y or a structure with an X and a Z. And the typing system knows he can get out the X field because both of those have an X. But he couldn't get out the Y or the Z because he doesn't know he has it because it depends which way the random point flip goes. So when he's actually evaluated, the first random is true. So it evaluates to the X is 2, Y is 3 when he gets X field out, which is 2. You'll notice that .x here, whoops, no, don't do that. .x here is the same syntax as .0 and .1 for pairs, and that's because they're completely, it's the same thing. My pair function just makes a structure with fields labeled 0 and labeled 1. Is as if I did, this is a field label, is what my pair does. Is that obvious? We can get done with structure.
What would happen if,
sorry, go ahead.
In the previous example, what would happen if you access temp.z, but you got the first result back? Would it be runtime error?
Yeah. Bad error messages for me, but I'm telling you, temp can't find Z. So It's an error. This would be well, you see, missing field Z. It's a compile time error.
Compile time. That's nice.
Yeah, it's strongly typed. So there's a parsing step, which you can have syntax errors on the parse. Then what you saw down there is in the stack trace compile step, calls do Hindley Milner, which does prep tree and then runs Hindley Milner. During prep tree, I've already discovered that it's a type error and you're done. Here's a function which is going to multiply his arguments, giving the area of a square, maybe, or area of a rectangle or something. So he takes this function takes an SQ, which has to have an X and Y field. So I pass it an anonymous struct with an X and Y field. So the structs are full first-class citizens. They can be passed into functions and evaluated every which way. Are we done with structs yet? Have I got anything more exciting with structs here? Not really. Let's see here. Let me get a more exciting thing. This is me finding a bug from a long time ago and turned into a cyclic self-reference again. Oh, this is a linked list guy. Yeah, let's do linked list once and then I'll be done. So map is a function, that's the curlies, that takes a function and a linked list. Produces back what's going to be a linked list. Who has N1 and V1 for next and value, and next is the linked list links and value is your payload of your linked lists. To get a next one, I have to take a map of the function on the rest of the lists, which is called .n0, not .n1, and apply the function to the payload of list 0 and call it V1. So this takes a linked list, which is linked on N0, V0 fields, produces a linked list linked on N1, V1 fields. So let's go look at here's an example where I apply the same map call with basically a decrement function, whatever, and I make a linked list which has one entry. Then the list terminates with a nil, and the payload is 5, and there's some extra fields which are junky but don't matter because the typing system doesn't care.
I have a question. Can you name the struct? Can you not name the struct keys? Like just be like the first one, the second one, the third one, and do them by number, or are they always having to be named? So like, is that pair's job exclusively to have unnamed?
Yeah.
Okay.
They're not. They are. Pair makes named fields. They're named 0, 1, 2, 3, 4,
Oh,
5.
so you can just do 0 equals and then the. Okay.
And no, and the struct parser won't accept as 0 equals. With a tiny amount of help, it would.
Okay.
And then you could have fields labeled 0, 1, 2.
Yeah.
Right. This wasn't me being fancy on the struct parser. I called my standard id instead of id or number or something. This is one-liners. Okay, we're about done with structs. So this guy takes a linked list that's linking through N0, V0, however long that list goes, produces a linked list, which is N1, V1, and down at the bottom, you can see I've got it done already. So it's a standard linked list map call. I think I have some other ones, but no, I don't. I think that's the end of it. Okay, let's go do overloads. I think we have more than enough.
I'm just wondering what ignore equals 3 means. Like, why
it's
is
an
there
extra
an
field. I've called it the ignore field. Doesn't have to be called the ignore field. I could call it anything I
so
want.
it's just for fun. It's not meant to explain anything.
It is there to explain that the map call doesn't care that if you passed it extra arguments on the linked list, that's fine.
Oh, right, okay.
Yeah, but they won't pass through. They are dropped on the floor. That's what, and that's because the map that gets generated, the list that gets generated map is generated right here. And that guy produces 2 fields only, not any extra fields. He produces an N1 and a V1 and nothing else. So you don't get any other fields.
There was just one other question that when we're creating the linked list, we are appending on the head of the linked list, right? I mean, it's growing from the head.
Well, it's a standard map over a linked list like you would get out of a, first semester lambda calculus scheme Lisp kind of course, which means that we break the list down from head to tail and then we build it up from tail to head. So when I run map, he starts by saying the list is not null. Go build a structure. To build this structure, I need to evaluate his field arguments. To evaluate his field arguments, I have to go evaluate this. That means I recursively call map. So while I'm trying to build the structure, I first have to call map recursively. So to build this structure, I call map on the next piece. To build that one, I call map on the next piece and the next and the next, and you chain down the line until you run out of list. Now you have pending lists all the way down the line. And then you evaluate this thing function and you get a first guy for the last field. And then you say unwind, unwind, unwind. He builds the list up going backwards. So he effectively unwinds your linked list on your recursive normal stack, on your standard stack, execution stack, to get to the end of the list. And then he winds back up.
Right. But does that change the order of insertion? So if I insert elements 1, 2, and 3 in a linked list, the head of the linked list would be 3 or would it be 1?
So there is no, I'm only appending to the head, and the head is appended to from the tail side to the front. So when you say change the order, I'm not changing it from one to another. I am just telling you what the order is. It's not like there's a change of order. You have an order in your head. I'm telling you here's this order. These two orders may be different, so we have to go sort out what that means. But I'm not changing without changing in your head. But I don't know what your head is. What's in your head?
Okay, I was thinking that if you go ahead with, let's say you call insert of a value 1, then you call insert of value 2.
So I'm not
and
calling
then you call
insert.
Okay.
That's what I'm trying to get through to you. Is it's not. There's no linked list insert per se. There is just this step here. This is making a new head element, which consists of everything else plus.
Right.
Okay, and
Okay,
that's
so it's like the new element holds this. The new element holds the existing linked list.
yes. So in the land of Java, there's a linked list holder, and if you insert, you go to the linked list holder, and the holder now holds a new head of the linked list. In this case, there is no linked list holder. You just have the linked list in your hand at the point where you have it. But there is no separate, I'm the holder of the linked list.
I find it kind of funny how everyone gets confused with head and tail, and I just never use either terms.
Okay. Yeah, fine. Tail, though, is usually the rest. So head is one element and tail is the rest, which is 0, 1, or many. That's how I like to think about it, but it's fine. If you're linked list header, you're not a linked list element. You're just the holder of the head of the linked list, but you don't hold a value yourself. All
it's
right.
Also weird that the first element is the tail. I mean, wait, is that right? The first element becomes the tail? If you have two.
I'm sorry? The nil is the no more elements. So here I am building a linked list, right? It's the element question.
My question was just about heads and tails. So if you insert two items, is the first item the head or the tail? Because
the last item that gets inserted is always the head.
Last item. Right. Yeah, so I always imagined it the other way. So I just know that whatever I think, it's always the inverted. Because I always think root.
It's implemented like a stack.
I like to think the head is root.
It's just an immutable stack. Like you put things on the top, and you can only grab the thing on the top, and you can't put things anywhere else. You can just put things on the on the top essentially, and you're just making a new thing. There's no holder.
No, I'm not confused. I just don't like it.
All right. Yeah, there we go.
Yeah.
So other than syntax errors, because I fixed them for the demo that got lost, I have added a second element. Maybe that helps people figure out. Here is the end of the list. Here is something nested internally. Here is what I would call the head of the list. And then it just evaluates to being the list with every, with the values all decremented by 1. And,
see here, I would consider 5 the head of the list, and the list
Yes.
17, the list of 17, the tail,
Yeah.
and
Oh,
the,
I would
like,
say, well, yeah.
the,
No,
like the things starting with at and ending with 17 semicolon curly brace. I would call that the maybe rest.
that's
The
the tail,
tail
which is the rest.
yeah. It is the second of the pair, but or not pair, but it's like the
Yeah.
it's the
Yeah, something insert. No, nothing insert the tail end, levo. When you unpack the list and map recursively, you come down to having just the nil in your hand. Then you unwind one layer of recursion and you add a guy and the rest of the list happens to be nil. That gets you N1 is nil and V1 is 16.
I might just be thinking IOU ring, but I have a feeling something as like inverts the entire logic. I don't remember what, but I have a feeling something.
You're kind of correct. That's what this
It's the
recursion
stack.
does.
Yeah.
This recursion chases the linked list all the way down to the end. It's been unwound on your stack, and then you rewind coming as you unwind from your execution stack.
Does it mean if you give it to can get Stack Overflow if you give it to
Oh yeah,
big
oh yeah,
blitz?
yeah. There is a way to turn this into a true tail recursive call, which can turn into a loop and be highly optimized and blah blah blah.
Yeah.
But I'm not doing that. This is a
Yeah.
standard trivial SDK machine.
Okay, cool.
So yes, if I handed you a list of 1 million elements, you'd Stack Overflow and die. Or if you handed me a list of, okay, are we ready to do overloads here?
Yeah.
What the hell?
Absolutely, yeah.
Okay, so here is an application, a call of an add and something and the two. Okay, what's the something? Well, it's a struct and a dot and a field name underscore, where you can't hardly see that. I'm going to leave my cursor off of it. So what is a dot underscore field? Well, it's a field that I'm going to infer. I'm going to figure out which field you meant. And so here I figured out you meant field I, and I evaluate you as dot I instead of a dot underscore. And so I load up the 1, and then I add 1 and 2 and get 3. Here I have X as the same struct, but I'm going to use it twice. In each place, I'm going to evaluate it to appropriately in its own context. And I'm going to get, it's either a 1 or a 2.3 and do the math. Well, I mean, yeah, let me carry on. I'll go talk about more things here in a second here. So is that clear? These, as with lambda calculus, these get ugly fast. So here's increment is the name given to the struct. The struct has 2 fields, an I increment and an F increment. The F increment kind of lies. He doesn't actually increment by 1. And I go get 2, the reason I'm using pairs, it's a convenient way to get a couple of things out of it. So he says, give me the correct increment in both contexts. And he says, yeah, no problem. So in general, I can pull out sort of arbitrarily the right answer. So here I have function of no arguments where I say, give me the right thing. And it gives me the right thing as needed.
Is F plus a special addition for floats?
F plus is floated add, yes.
Got it.
And that's because it's strongly typed, and I have int makes an int, or I have float makes a float. And the reason I went to overloads was exactly to get the primitive operators in AA to be able to pick the correct flavor of thing without getting weirdnesses in the language. Like you get many languages, you get a weirdness. That's a comment myself. It's no longer true. Let's see here. So it works for structs as well. Function is, it is dot underscore, which pick correct answer. I have a struct with an A and a struct with a B, and which one do I want? Well, every time I'll just pick the correct answer. And this is statically done. Like I know at the time I got down to here, the function will return me a structure with an A. And when I get down to here, function will return me a structure with a B. they could be completely unrelated types as well. See somewhere, and this is where not yet. I'm gonna, here's I'm gonna get a little uglier.
Can we go back to the previous example once?
Yeah.
What are we inferring in this? Like A and B, aren't they obvious in the structs?
Yes. So function, what is the type of function? Function is a typed as I take no arguments and I return you something, which is the correct something in each use case. So that's not your normal lambda calculus behavior. And I'll have examples where function returns wildly unrelated types,
Right.
which he can do because he's actually, because of the of how the underscore fields work.
Got it.
I got a few questions.
Yeah.
The nonsense question is, why is there a semicolon? But my real question is,
I'm sorry,
the
where?
dot
Here?
yeah.
Because this form function is equals to, if you do the Leibniz calculus, you'll see this all the time as let function equals some definition in some body.
Okay, so you're omitting the in by using the semicolon.
The semicolon is the in, yes.
Okay.
And the reason for that is so I get code that looks closer and closer to C code, but it's actually still type lambda calculus.
Oh yeah, I was gonna save this comment for the end, but this is very functional from a guy that writes Java and C.
That's correct. But
Yeah.
but what you don't know, Levo, is I've been coding for 50 years. And I have coded every possible coding style on the planet. So I write Java and C, but I can write lambda calculus. I've written Scheme. I've written eLisp and I don't know, 3 other Lisp things. Elm, yes, very, very functional language Elm. These are all part and parcel.
Why the period underscore? Because it seems to me that you could just return the pair.
It's not a question of efficiency. It's a question of what the fuck can I do here? Sorry, pardon my French. So I am picking one element of the pair, and which element should I pick here? I'll have more examples in a second where this gets weirder and weirder and weirder. And my end goal is to say in AA, I can have infix plus subtract, multiply, divide normal operators that do things with ints and floats and strings and auto inflate them or auto widen as necessary without the user needing to say anything, and have a strong lambda calculus behind it as well.
Can you show the type of the function?
I can.
Just curious how it looks like.
No, I can't because I can't spell. Let me try again here. Read my error message. Okay, so the type of the function is this, and I was going to show this coming up in a little bit anyhow. What the fuck this is in B, and it returns me a B. Okay, so it returns me a completely undefined, unspecified thing, and it takes my overload descriptor. And an overload descriptor is a thing that I can boil down to a small table of field offsets. So when I say I have an overload field, what really happens is I have a virtual field, like a virtual call. I have one extra load offset to get to it over a normal field.
So that's how you resolve this at the end.
Yes, and I will show you more ugly things for which this becomes more and more obvious. Yes, you're correct. There is a thing that should be suspicious. Like, that seems easy. That seems hard. That seems easy. No, it's really hard.
Just one last thing to this example.
Yeah.
That if, for example, the dot underscore was not there, would the right way to access A would be function dot 0 dot A, and accessing B would be function dot 1 dot B? Would that be correct?
Okay, so get rid of this.
Yeah.
So just returning a pair.
That's
the
right.
pair, right? Yes, I could say dot 0 dot A.
And then dot 1 dot B.
Yes.
Got it. Okay, yeah, it's making more sense.
It runs. Okay, so I can also come through and say underscore here, and gives the same semantics.
Oh, that's nice. Yeah.
So that's where I'm headed for here. Let me make sure I didn't break myself. Thank you. Okay, so here is a similar behavior where I have instead of using pair, I use structure, so I give names to the fields. Q, I'm going to guess which of my Qs. I have an int version and a float version. These are both functions. Which function do I need? Well, I need either an int function or a float function. And I should probably have a random here, but I can leave it at 0. I don't care. And as a 0, it returns me a float version of things. But if I put a 1 here, he's going to give me the other guy. And you'll notice that he knows the answer is int or float directly. That's kind of me cheating on
You
integer.
have an expression where instead of 1 in the if, you have an underscore.
Well, I can do rand. I can put an underscore. I have to put an underscore.
I was just curious if you could construct this with the hole, so that something later could fill that hole. I understand the underscore acts as a hole in the language, right? It's unification variable.
It is like a field load, except it also needs to get which field. It needs two things. It's going to be a standard field, and also it needs which field.
I see. So it's like a unification variable for the field selection.
Yes.
Right.
Yeah. And mixing basic types, because you can't do that on this example. Okay. We good with this example? Before I move on here, like I said, I'm going to start ramping these up kind of nasty here. So which Q should I pick here? One takes an int, one takes a float. Well, bar takes an X, and then I'm going to call function and hand it X. What is X? Well, X is either an int or a float. So I am passing as Matt points out, the unification variable through multiple layers. It can go through any number of functions.
What is F2I?
I'm sorry?
What is F2I?
Convert a float to an int.
Okay. Oh, just like typecasting. Got it.
Well, it's a standard conversion, so it changes the actual representation of the value. It truncates, or I guess it rounds, so you lose information and stuff like that.
Right.
Like here, I am we put a 0 down, and that'll go to the other side. And the answer is 4 because he rounded 3.9 to 4. Then we put random here. And then he says the end result is always an int 64 because both of these Q functions return an int. So it's well typed. And if I execute it, random says go get the first guy, which adds 1 to 7. I think that's, yeah, fine. Okay, so now I'm going to get a little uglier on you. So here I have 4 choices of all combinations of float and int. So the suggestive names I, IF, FI, FF tells me whether your arguments are ints or floats. And I go to bar and I just call function with no arguments. Pick the right guy, dude. So he's got to pick one of the right guys for this situation where he passed an int and a float and hand it back to this guy where he calls bar, which is handed either an int or a float in the first argument. So, and then Baz is called right there. So for this guy to work, no, I don't want this one. I want eShell. Thank you. For this guy to work, this function call, these 2 function calls are either going to return me int, float, or anything thereof. It's returning me one of many different functions. And this is where the overload thing starts getting really weird on me. And so, what is the type of these various things? So let's go look at the types of things here for a second. What is the type of function? Oh, that's kind of ugly. What do we got here? Well, it's typed as a function. It's going to return me an A, which is in A, which means I have to do something with this pattern match thing. Oh, go away. What is this? This says I need to do a pattern match of a structure. It's got 4 choices. And the pattern I'm matching is A, which can match any of them. So this is an unresolved virtual field lookup. I can't resolve it. I can't resolve function as it stands. That is to say, this underscore here can't pick one of 4 fields by itself.
It would be technically more correct to call it a subtype because it's all possible choices at once.
It is all possible choices, and I don't know which one, so I don't actually.
So it's a subtype. But the subtype.
I don't actually unify any of these types. They could be ununifiable types, ints and strings and functions.
A subtype can be
Okay.
sum of
okay.
any type. So
sure,
a choice of any type can be.
This
so,
is for me. This is I'm thinking of it as a delayed.
It's kind of a few interpretations come to my mind as in the previous talks I say it's akin to an unbound symbol because it will be filled in later, but it can be filled but from all choices defined previously. So it's not any symbol, but it's any of these predefined symbols. It has to pick one.
Yeah, it has to be one of okay.
But one question would be, can you for debugging purposes, when you call bar, can you call or when you resolve the function, which resolution, can you inform which name was it for debugging purposes? Because sometimes can you get confused from which function get picked. So you have a name, like for example, QFF on the top of the list.
Yeah.
So if you resolve it, it would be good to attach some kind of debugging information that
that's
this
in the type that information's in the type info, which I can get by asking for it by just naming that thing, which is what I'm about to do a demo.
Okay, sure.
Okay, now I get for bar, I get a bigger type. The double square brackets is I need to go do something. I have an apply, that's the A. It's a specific apply point. One of these 2 apply points gives me one description of the virtual field, and the other one gives me a different one. And so inside of the apply for one of those fields, I have a match where I'm trying to match the Q whatever choices with a guy who's got a recursive virtual field table, which is unspecified and actually unused, something that I haven't seen yet, and a digit number 2, an integer 2. So one of my matches demands I'm going to get a 2 for the second argument. There's another apply point floating around. There's several. Some of them don't matter because they go to primitives, and the primitives don't need the lookup here. They're not taking arguments, so they always have a free variable. I have another match here, which is matching against a float 2.2. So what I've been doing here is I'm building up different tables of what my choices will be and what the matches will look like as I go. So one of the matches will be a matching against a 2 as one of the arguments, and one is a 2.2, and that will turn into a function match where I have to match the second argument to an int or a float. And if I go down here to Baz and I run myself, I get an even larger table, except it starts to resolve here. See, I believe it's going to resolve on me. No, it doesn't, because I didn't evaluate Baz. And I evaluate Baz. How do I show you how to evaluate Baz? So here I have a match for Baz where it's going to be matched against a function which has 2 ints, 3, 2 there, and they'll return whatever that function returns. And I have another match, and because I have 4 calls, in the end I get 4 matches. Here's a match of 3 versus 3 and float, and so on and so on. I have 4 matches in here for each different combinations I'm looking at. Those matches are going to resolve when I call the thing, and I have to go figure out why they didn't resolve without calling it, but they will resolve to an individual field. And how do I show you that field? Let me think about this. I do know at the time that I am done here on this function, I can stop it in the debugger and show you. He's already matched. Here, the table for bar will be half completed, but here this will be, I'm handing you a table where one side will be a .qff and one side will be .qfi, and so on and so forth. So I build up these tables, And that's what this descriptor down here turns into. And if I take the junk guys out, and I take the match info out once I've successfully matched, I end up with a two-dimensional table that's got, ends up with an offset of pick one of these 4 fields. And at this point here, at this bar, I will take the table. So here I'll generate a table and hand it in as a hidden argument. At this call to bar, I will pick the left side of the table or the right side of the table. Literally, I have a table in a register, and I'll add a fixed constant number to pick left or not if I didn't go. So I'll add a register, I'll add 8 to it. And then I come down here, and I'll take the same register as the hidden argument, and I'll add 4 to it or not. And when I come down here, I've passed in it as a hidden argument, and I'll fetch out an offset. And the offset will be to 0, +4, +8, +16, or whatever the field offsets are. So the actual overheads means I'm passing a value in a register that I'm doing a tiny amount of work to as I go along to resolve the overload in the end, the overload field in the end.
So you basically have, when you nest those tables, you have a nested pattern matching, right?
Yes, but it's all resolved at compile time. Yeah.
Are you fully resolved this at compile time?
Yes. This all turns into constant offsets. That was very much a goal. And if I don't have it right, I've screwed myself up here. This is probably,
Nice.
this is me trying to show the different, this is just me showing the different things here. I have an easier example to reason about. This one is just me saying, hey, you're typed as A, B, C, D, or all ints, but the actual values, according to the random, went left, right, up, down to pick which of the different fields I'm doing.
One question would be, what would happen if UI, QIF are structures and not functions? We come back to the idea, if you can...
Let me go show you what happens if I hand you more, I'm going to say, no, that's the next fact one. Let me do fact in a second here. I think that one is, where'd my color choices go? No, don't tell me I lost my color choices. This is part of the things here. That's this is a simple enough one. So here, color is a pair of a number and a string. I can add one to a number, and I can tell you the length of the string. And the reason I'm bringing this one up here is because it shows that I can return different values here from the fields. The fields don't have to be uniform. In the example 8, it was maximizing how far I had to stretch the recursive nested fields. And so I kept everything uniform, so it was easy for me to reason about the test case. Right?
Can we go back to that previous example?
Here I am handing you back a thing which has non-uniform choices. I'm not only picking functions, I'm picking between strings and ints.
Right. But here, if the strings and ints, like for one of the options, if the elements were the other way around, like it was red and then 1, 2, 3, but for the other pair, it was still 4, 5, 6, and then blue, would it still be able to figure out?
No, you're gonna get a different kind of error here. Mixing basic types. The pair of blue and 1, 2, 3 doesn't mix as the two sides of an if. So these have to be uniformly laid out.
Right. Oh, so the type is completely defined. There has to be a pair of an int, then a string.
Yes. They don't, I could reverse them here and leave my underscores alone. And he's all fine with that. He picks the correct field, even though the fields have flipped, but they have to be flipped in unison.
Right. Consistency is important. Got it.
That's me showing you an ugly example. It's an interesting one, maybe. I have a better color choices ones here. This one is, I have a function takes an x. What is x? Well, x is in the function position. So I'm sorry, x has a structure which contains a field, which is a function. X is a structure which contains a field which itself is a structure having a v.
So the underscore can only pick field, or
it only picks amongst fields.
Can you return a structure itself? The underscore.
Yeah, you can return a structure.
If you return a structure, you can simulate a subtype. So
I do
based
that
on
all
the
the time.
underscore, you will return a type or set one of the multiple choices of the structure, which is something.
I hear you. I have a strategy for making subtypes that are a little closer to what you get out of a Java subtype in the pure language
Subtypes?
calculus. I'd have to
Oh.
look at what you're saying there. You're yes, and I'm very much the underscore has a lot more flexibility than what I intended for it.
Mhm. If you can extend it to the underscore to select a structure, you can simulate some types. No
It
problem.
does. I showed that example earlier. I have an example where I
So
select
you can cook up some types to test.
I imagine so. So let's finish out, and then we'll come around to like people's want cool looking whatever.
Yeah, just thinking what's on my mind. So
yeah, right. No,
let's
there's
continue.
something going on there.
Yeah.
So here my table descriptor says I'm gonna, and the function says I take an A and return a D in a table descriptor. And the table descriptor demands that A is some kind of structure which buried in it has a function. And also at the other site where I'm going to use it, A happens to be A is a structure that has within it a V field. And in fact, the argument to the function is going to be whatever C is. And that's this C here, which is the function will take that C argument, return a D, and that's the overall thing returns a D. So I can have these partial descriptions like this, and I know something about X. X is a structure. It has a field that contains a function. It has a field which contains another structure with a V, without knowing what those fields are called or labeled or anything. And here I am showing an example of using that, where X is passed, in fact, a structure. It has two fields. It could have more. One of the fields is a structure, which has a V field. One of the fields has a function, which takes a string, and that V field had to be typed as a string. So he picks out the A and B appropriately and declares this is correct and works and well typed, and will execute it.
This one hurts my head. I have no idea what's going on.
Okay.
Specifically, why does it? I specifically don't see how the ABC is being combined with the more string.
Okay. So in this guy here, he says, I need something X, which is a structure. Oh, I've got it. I've got this structure here, right? That's my structure. And if I pick these choices for my underscores correctly, let's call this B, and let's call this A. I go to X.B, oh, I'm a function, which does string concatenation of S and the word more.
Okay, so yeah, I get it now.
Okay.
Yeah, it's just I wasn't paying attention to the first line enough.
Yeah.
But yeah, now it makes sense. Yeah, I'm not used to functional.
Yeah, I've been hurting my brain on these things for 6 months now. Two unrelated structs. What is this? Oh, this is another version, just exactly what you were looking at. But it's not very exciting here. Stir is a function internally that turns an int to a string. Just preprints an int as a string. So, you know, this says, go grab this guy, and this says, go grab this guy. And pull out, they're two different structs, so they pull out two different things. Where's my pretty color one? Here we go. Okay. So here, color is a function which takes a hex value for a color and a name just to pair them together. Make a red color. Make a blue color. Make a function which is going to lighten the color. And it's going to take a color, and it's going to make a new color where it's find from the old color where I add one to the hex value and I add the word light to the name. And then I make a pair of light red and light blue. And of course, light red reads as lettered, but yeah.
Just one question. In the example previous to this, how does the selection happen? Yeah, in this one.
Yeah. Okay. So I have a pointer needs a thing which has a struct with an X. Oh, both of these have X structs. So that's not sufficient already to say which one.
Right.
But then this x here has to be in the function position. I need a function here. And this x has to be in the position where I need to be the argument to that function, whatever that function is. So if I come down here, I say x is a 3. 3 is not a function, can't be there. X is string, a stir, which is a function. So I put this one here. This is the function. Now stir takes an int, returns me a string. Oh, this guy's typed as an int, so he must be the correct guy. So done. This is standard Hindley-Milner unification, except for the field selection bit. Once I've got my fields picked, then I standard Hindley-Milner unify, and all my ints and strings all line up, my functions, ints, strings all line up, and I declare victory and say you're well typed.
Got it. That makes sense. Thanks.
Okay. All right. Let me see if I can find the evil factorial number 1, and then go to evil factorial number 2. And I might have to grep for it. Is this the evil? This is the evil one, number 1. Okay, so here I have factorial down here. What the hell does this factorial look like? Well, I took the original factorial and I replaced my test for 0 with a paren greater than, and my multiply became a paren multiply, and my subtract 1 became a paren subtract, and the number 1 became a function also, because what the hell are all functions for? Well, the function for 1 says pick either an integer or float 1, and the function for subtract says pick int or float, and the function for multiply says pick int or float, pick int or float, pick int or float. And so I'm defining factorial where I can pass it either ints or floats. And here I'm running factorial on a 3, which factorial is up to a 6, or 3.1. What the hell is factorial 3.1? Well, it's not a 3.1 is above a 1, so go ahead and subtract and look at 2.1, look at 1.1, look at .1. Return me 1 times 1.1 times 2.1 times 3.1, or 1 times 2.1, yeah, times 3.1, yeah, and I get 7.161 plus round off crap. That's a pretty ugly factorial. But you're seeing where I can have generic operators that work on ints or floats. I can have it work on fucking matrices, and you could define factorial on a matrix, for instance.
One question: what's the f greater than for
floating
the
point?
function?
Floating point greater than is something greater than something. So in an infix operator, you can imagine me saying this if I were doing this line infix.
Right.
Is n greater than 1.
Okay, right. Yeah, then it's a standard factorial. Got it.
Okay. Here's another factorial, which is a little cleaner looking. This one actually should not type error here, and I was working out the bug, which I did get the bug worked out. So I'm going to come around and describe a second what's going on here. Let's read factorial for a second here. This says factorial tests for are you a 0? If you are, return the constant 1. If not, call n.mul._. On factorial of n.sub minus 1. Okay, what does n.mul._ mean? It means go pull out the multiply operator and pick the correct function from the multiply operator list of choices. One that takes ints to ints, or ints to floats, or floats to floats. Same for subtract. Pull out a list of choices of operators, pick the correct one, and type yourself. And then, subtract 1. Okay, what does it mean to have a list of choices here? Well, here's IWrap and FWrap. These are ugly beasts. So let's look at IWrap here. IWrap is a wrapped integer. And that means it's a function which, given an integer, returns the wrapped version. Okay, what's the wrapped version? The wrapped version is structure, which has the integer just copied into the I field. It does an is 0 test up front if your I is equal 0 or not. and multiply, which is a list of choices. And the choices are multiply int by int, multiply int by float. And if I multiply int by int, I grab the int field. I know y4 is an int, grab the int out of it, multiply it, and rewrap it. That's what that function does. The fwrap version has to take an int argument for self and turn it to a float. Grab the float from the other guy, do an f multiply because you got an f float because you're doing a standard widening operator, wrap it. So IWrap and fwrap are wrappers around functions that let me take an integer and have a multiply operator which has a list of choices, whether the other guy is int or float, and does widening as you would expect when you mix ints and floats and multiplies and add, subtract, multiply, divides. This is where I went to on AA and was using the overloads for. And in all the syntactic sugar gets wrapped up and hidden from you. So when you look at this as an AA line of code, in.mul.1 looks like in times factorial of whatever in -1, just in the exact normal order you expect out of an infix operators, where the multiply internally expands to look up the multiply field on the thing on the left. It's going to return you a list of choices. Pick the correct one. Same for in -1. And that's how I can get to strongly typing factorial where it's either ints or floats. But he does so because he passes along from the call site, the invoke site of factorial here, whether or not I should be pulling out the int fields or the float fields. And then that has efficiency issues that can turn into specialization, but I strongly know everything about that. And that's sort of the end of my demo, which went, an hour and a half, so it's probably too long. Anyone want to ask any questions before we say everyone's brains are hurting now?
No, the information here is a lot denser than one might think.
Yes, it got dense fast, and then you can't hardly figure it out. I've been sorting out how to debug, but I think I figured myself out. In the end, I have an answer that I like. I'm going to pass an extra argument along. It's going to do very minor things where I add numbers to the guy or I load one field in. Turns out in recursion, you have a field that has cycles and you load the self cycle in the field, and that works out fine as well. And then when you finally get down to the virtual field load, you grab an offset and then you load from that. You load a pointer on the left, and on the table on the right, you load an offset out of it, and then you load at the offset from the base on your left.
So the offset, yeah, that's the only efficient thing I can figure out. The offset, once it's resolved at compile times,
it's all compile time resolved, so you get
and
a constant
once it
number.
knows, it's offset known statically.
So that's my last 6 months. It was way longer.
Congratulations.
Yeah, exactly.
To even make it work. So the underscore, as we talked a few times, it's a neat trick to go around all that. So yeah, a hard work.
Is there a program you want to write with your language with AA?
Well, I wanted to write all kinds of, cool systems-y programming things. Everything I've done here, I know how to fold away the cost on and turn it into what you'd get out of a C compiler. So these are all things that have relatively straightforward implementation strategies that would give you, well, what would you get out of a C compiler? The one place where it gets wonky here is fact, where to turn it into factorial, where it's all done with integers and without extra field loads on functions, would require specialization. But exactly that dynamic table type is my specialization strategy. It lists me all the places where I need to do something. And if I look in the top level of a table and it bottoms out in one kind of thing and it bottoms out in another kind of thing on a different side of the table, that tells me right there I need to specialize. Then if I hand you a factorial that has the bottom half of one table or the factorial of the bottom half of the other table, in each of those two cases, I get all constants all the way down. And literally, I can now just plug in constants, load the constant field, and then they inline. And then it turns into what you expect out of factorial of ints or factorial of floats. So there is an obvious strategy baked in the types now for how to specialize. And that's what I was missing before. Hey, Aaron, you missed it. It was an AA update. It was the brutal type unfriendly AA update.
I guess I'll have to catch this one on YouTube.
Yeah, this is pretty.
Hopefully you were
cool.
sharing screen the whole time.
Yes, somewhere early on I started sharing screen, and you got it shared screen. Here's the easier version of it showing the underscore. I mean, this is all about how to do the underscore field thing. I'll step this through really quick. Everyone else has heard this already. Color is a function which takes a hex value for color and a name for color. Make two colors, a red color and a blue color. I make a function light, which is going to lighten a color. It takes a color, it produces a color with a color constructor. He takes the existing some field out of the color and adds one to it, that lightens it. And he takes some field out of the color and he concats the word light to the string name, and then he evaluates it. Come back. I don't want that. No, I want.
And it figures out the field name by the type.
And he tells the field name by the type. Yes. So he knows if I swap the fields around, it won't change the outcome. No.
And that's for APIs where you don't want to specify the names of fields. Why?
Exactly. I typed with you and now I lost myself. Thank you. It's exactly what I was doing with factorial here in the ugly case. So here is a factorial function. Factorial function takes an n and tests for 0, returns a 1, whatever C1 is a kind of a 1. Or he calls multiply, goes the multiply field out, loads exactly what the correct answer out of the multiply field, which is which correct function to grab. Also calls subtract, grabs the correct subtract function. This is AA's internal parser. Oh, is my wife calling? Hey, I'm on Coffee Club. Well, I didn't do it. I'll go look online in a few minutes, but I can't do anything now. Yes, you have to say no and walk away, or grab your own card and I'll pay you back. All right, bye. Yeah. Where was I?
So this is the, I would like multi-methods and dynamic dispatch and all these things to fall out nicely from the type system.
That's correct. And
so it's really convenient to have a bunch of fields that don't really have names, because I don't want to pick them by name. I want to pick them by which is the thing that makes the types actually happy. I'm trying to do multi-methods here. Thank you.
Yes. And it's not that I am specifically doing multi-methods per se. Well, I am though, but it's not really a multi-method. That's interesting. So it's me doing, well, I'm calling it virtual fields now.
But if you have a name and then dot underscore, it's most closer akin to an overload. So a more function called with a different argument. So it's most akin in this form to an overload.
I'm using it as an overload, but I'm also using it as other things. There's no overload is a use of this.
Yeah.
I can build up I believe I can build up virtual tables at userland time and run virtual call like effects, which is basically what I'm doing here, where the user gets to specify basically what a V table looks like, more or less. Yeah.
I assume it doesn't care whether the thing is a struct or an array, right?
I have to have.
If I have a list of functions and I'm just like, grab whatever function in this list works.
Has to be a fixed list so that I can at typing time tell you I found the correct function. There's no runtime behavior here.
Right, but that fixed list could just as easily be a tuple or a struct or whatever.
I found the bug. My wife entered my PIN incorrectly. Let me tell her. No. She got the wrong pin. That's what got her kicked out.
Would you like to share the pin with the YouTube audience?
It's the same pin I've used for 40 years.
Oh,
And apparently it hasn't been leaked by anybody. So you have to guess from what would I have picked my pin 40 years ago as?
but that narrows it down.
Yes, exactly. All right.
So
Wife sorted.
with a dot underscore can return a structure. That was maybe Aaron.
Yeah,
asking.
I can totally return a structure. I had one of my early test overs just showing me returning a
Yeah.
structure. I don't remember which one.
Mm.
That's peeling out a structure.
Mhm.
That's peeling a function out. And I get fancy function selection.
Yeah, with the dot with underscore v. Was that
There's a V in there. I had the AB one too. I was going to grab the AB one.
okay?
Which I don't claim this guy. Here I'm returning you structs.
It's dot underscore.
And I know which structs I'm getting because one of them I need an A field, one of them need a B field, so I can tell them apart.
But if the underscore has a chance to return multiple structs, and can you match over them somehow?
Yeah, I'm matching here. I'm matching because you have an A or B, but let's keep going. Some of these structs have other weird things going on. That's the simpler version. Hang on. That one is pulling out the wrong just functions. No, I went down the function path. Let's see, was it under the later set here? Somebody gonna tell me which one I need? Drop no test over 10, 11. That's this one. Over 11. Too many of these things. Oh, here we have a scene, but that's me still picking functions out. That's the first one. Where did my other one go where I pick all kinds of this guy? Yeah, right. This guy. So here I am picking between here I'm picking between a struct and a function. So that's not fair. You want different structs.
Yeah.
Yeah, I have to be able to tell which struct you get at compile time. So the usage pattern on the structs has to tell them apart, but it's full Hindley-Milner on the struct bodies. So however they fall apart out of that.
So
if I wanted to use this syntax to write the overload of the @ symbol.
You can't redefine @.
You have @ meaning something?
Yeah, @'s not a primitive you can rewrite because a parser doesn't know how to handle it.
Interesting. I assumed I could say underscore @ symbol underscore.
Sort of the same thing. You can, but not the @ is making a struct. No.
So what would happen if you add C here, C equals, and it has it has a field V, but it's a different type. So how can this be disambiguated? So if you select the V, it has to pick the context.
Right. So in order for this to work, here he can pick B for the function.
Mm-hmm.
Because he can pick B for the function, he needs a string on that. And V isn't a string. The C line isn't a string, so he fails and says he doesn't pick that guy. That doesn't work. Now there's a separate thing that says, well, I'm going to add another function, another field, which is also a function, but it takes a float, which I get out of the other dude here. This guy, I want to float here. Now I should be ambiguous and should give you some sort of crash. There you go, unresolved dynamic field. That's exactly the crash I'm looking for.
Why is that ambiguous and not determined by the call?
Okay. Exactly. Well, if it's determined by the call, which one is it? Because the call is right here. I'm in the call. This is me doing the call. The call is happening right now. Which one of these should I pick? And why should I pick it?
So,
well, right now you haven't specified enough types.
Yeah, it's unspecified. That's the error you got back. Unresolved dynamic field is I didn't have a specified. I couldn't pick between these two choices.
But if you call this outer function with a 0.1.
I'm sorry, I call what outer function with a 0.1?
The X goes to X underbar.
It selects the V field from whatever.
Maybe I'm reading parentheses wrong.
Are you on your car?
I am.
Yeah, okay. You trying to
My
read?
audio bad?
It's actually pretty good, but it's a little tin canny. So the A and the B fields taken together are consistent, where the function wants a string and V contains a string. The C and the D fields are consistent, where the function wants a float and the V provides a float. But I have two consistent choices. That's ambiguous.
Yeah, the whole example is to select the V from this possible struct field. Yes.
Yeah.
Yeah. So how can you, in the A example, the V is a string. In the C example, the V is a float. So in order to resolve it, should it need more context or it hasn't, it can either resolve to a string or it can either resolve to a float.
Right. I can add more constraints by using more x dot underscore things, or I can remove choices. So if I remove the choice for A, I have no one who produces a string. He resolves to the float side of things. If I bring that back and remove the B, again, I have nobody who has a function that takes a string and it resolves. If I remove the C, I have the extra function D, he has nobody that does a float, and and again, so if I drop any one of these things, it's resolvable. As soon as I have them both, no, it's not resolvable. They're both equally good. In order to defeat.
But if I go to that top line and just add a colon FLT.
Okay, I don't have any type annotations. So to add a colon FLT effect, I have to force a float some other way. So I can claim that V needs to be a float because I'm going to use it in a float context. I'm going to say float multiply of x dot under dot v of 2.3 float. Now I'm passing an extra argument. So my function has to take an argument here, a second argument, which is going to be ignored by both of these functions.
But it'll resolve it anyway.
But it'll resolve it anyway because you won't, because I didn't do I have a typing error. That's a syntax. You can't write shit. Syntax error. I have to go find it now. Why does this guy care? He's missing error. I mean, error mess. My error handling is not super good here. Then that's sort of, part and partial with having a primitive thing. If I
extra parentheses on the
yeah, exactly. Oh, exactly. An extra parentheses. There you go. Maybe. See what we get here. Unresolved dynamic field. Okay, so he is not unambiguously resolving this still.
Because it's ignored. It's just dead code.
Actually, I suspect that could be the case. Hang
like
on.
Those constraints don't mean anything. They're in dead code.
Well, but this is not AA. This is an SEK machine that's got an evaluation strategy.
Yeah, fair.
But there are places where things that don't get used don't show up in the Hindley-Milner typing anyhow. It's not dead per se. No, I still can't. It's using it on the one side, not on the other, and it still can't type it. And then that's because I went with a pattern that said you had to be more unambiguous. I actually go look up why he doesn't like resolving this, but you have to be more unambiguously typed. Let me get
just one question, that in an ideal machine, this is supposed to resolve correctly, or is this still supposed to be ambiguous? Like, because we added that new constraint that x dot underscore dot v should be a float.
Okay, in a standard SEK machine, there is no dot underscore. This is syntactically invalid because you used a dot underscore. So I'm now on the realm of I have my own thing. It's an extension. Now, what does my extension do? What do I intend for it to do? Well, it does, it does what I want to do, or maybe it does what I coded it to do, not necessarily what I wanted it to do. Okay, what did I code it to do? What I coded it to do at the moment, apparently, is to say this is, I didn't say my thing here. This is ambiguous, and so he says, no, I don't get it. Why is he saying it's ambiguous? Now I have to go hunt up why he thinks it's ambiguous. And it's because he'll find a binding that works in 2 out of 3 cases, and that's not enough to say no on. Like the string version here where he ignores this choice. Oh, well, maybe that's just it. Yeah, this is still ambiguous, straight up. Because if I do it as a string side of things, then I would just throw away, here, let me remove this. I'm going to grab a B here and A here. And he says, this works. So this one works. It's ambiguous. Because, you know, I don't fucking care. Well, what does he do for this guy then? For that to work, he has to have picked, he picked the mixed set from the other guy. He did like this. Those were his choices. And those choices work.
I missed the first x dot underscore, which means that it has to be a function.
The first one, the first x underscore has to be a function. There are 2 functional choices.
Okay, well, fine. That's fine.
Yeah, so there is a valid, so if I put my underscores back in, there is a valid picking of fields for A, B, C, and C, D, D, or C, D, C, right? He has 2 valid choices he can pick there, and that's where he says you're actually ambiguous.
It has to be a function in which in what you pass, it has to be a V, so it has to select on the second underscore.
And the 2 V selections are different here, right? If I put a B here, I'm picking the B, I'm picking the A. Okay. And then what's this one? Well, I'm not picking A again. That would be an error. I'm picking C. So this one works. Okay, so now I have 2 mappings, and therefore, you know, ambiguous. No, I fail on you.
Wait, the other mapping would be that we have x dot d first, then it'll be
okay, yeah. Do x dot d first. Now I need the C here and the C there, like this. And that one works as well. So the mappings are ABC or DCC. And in your heads, everyone's head, mine included, it was BAA. No, it was BAC.
Oh boy.
Yes, exactly.
One cryptical.
Well, right now,
this code would
don't use
take a lot of people to stare and scratch their heads. That for sure.
Right now, my intent is you don't use underscores.
Yeah.
I mean, you're certainly going to have to think about how to get those error messages, right?
Oh, yeah, I put a bunch of work on the error messages on AAA, and then I ran into the deadlock of, oh, what about here? And what about here? And this ought to resolve, and that ought to resolve. And they weren't, and I was getting weird errors when I should have resolved. And then I settled down, 6 months later, I think I got it. Now I'll go back and make sure those errors, look good.
You have to be able to construct every decision made. So
yeah. If this is an unresolved dynamic field, there's a long, now that I have it fully typed out, there's a long walk through the list of choices. And then I can hand you, I could go this way and I could go that way, and you're toast.
So even a simple expansion of the underscore would clear things half the way through, so you can trace which decisions.
Oh yeah, if I have known options that are fixed already, those I'll just resolve and say done, and those will show up in the error messages already done. But if I come through here and I give you, I'd have to come, I don't know how I'll do with this example. Like I was intending this to be done for my primitives, but it looked kind of interesting for userland, and then followed by, oh, things got weird on me. But if I come through here and say, I'm not resolving this, what I can do, what I can do is I can say, I'm going to pick one, resolve it out after I picked one of the choices, where I say the choice in our heads is this combination of ABC, but the resolving code doesn't have this kind of a choice given it to it. He doesn't give me 2 sets that are compatible. Instead, he says, I have an unresolved guy. I pick a thing, it doesn't conflict. I pick another thing, it doesn't conflict. I got too many choices, so I'm toast. But I could pick one for him of his lists and then finish out the resolution for the rest, then unwind and go back and pick a different guy and finish out the resolution. So I will pick a known victim and he'll be part of the error message and say, if I pick this field as this thing, then everyone else falls out this way.
Yeah, but if you change resolutions, it's not quadratic. I don't know. So how many choices you have to pick one?
Yeah, right. Right. That gets into the if you have used many underscores in your code and they're all dependent upon each other, you could have an exponential set of choices, and
So-
you're kind of shooting yourself in the foot.
So this is a 7, 8, 10 line program, and this program made scratch our head. So this is
true for all lambda calculus programs. For me, I can get short programs that like burn your brains. That's the kind of the point. Not the point, but it's a concise description.
You just
I mean,
flexing.
the fact that you can trick it into solving a Sudoku for you is not necessarily a problem.
I don't know that I could do that. That's interesting. You describe a Sudoku in a type system, then this would work. But I'm doing a very dumb approach where I simply
Yes, you have types 1 through 9, and you need functions for each of the constraints that represents each of the columns, each of the rows, and each of the blocks.
I'm looking forward to your Discord
Sudoku solver
example. Yes, and I will happily push it through. This is now on main, by the way, AA main under the exe directory as a one-line standalone executor that takes files, AA files, if you were going to go play with it.
So there you have it, Turing complete underscore.
Yeah, it's not clear to me that it's Turing complete. I'm trying very hard for it not to be.
I suspect so. Maybe.
It doesn't look like it's Turing complete. My guess is it's exponential. And you can't do infinite loops in it.
Well, no, he cycles in the types I totally handle. That's not the issue. The way I pick, I demand somebody goes first, which I think prevents exponential exploration.
Okay, that would make it a tree if somebody you have to pick someone.
Yes.
So listen, hold up. But if inside of the underscore resolution you refer another to the top level function, if you will, that needs to resolve again, that is a cycle. So inside the function, you refer it to the underscore, the first underscore, which would have to be picked up again. That is a cycle. And
okay, so break out cycles from exponential here. For picking yourself during resolution, if I pick a guy and as part of that resolution, I need to pick him again, he will pick the same way. And if that is consistent, I'm done. I'm okay with that. And that's the cycles that show up. While I am looking at picking A for the first guy, if during the resolution of picking A, I need to pick A as the pick for the x.a again, I do so. I pick A, I force it. That is, I've picked it once when I came through here. When I come through here on the cycle time, I pick it the same thing. And that makes it linear in the size of the cycle. It's not, I'm not walking the cycle, I'm just linear in the size of the cycle, and that's fine. And then if that's consistent, I'll pick my A and I'll walk away. So then I go ask that question for A and B and C and D. And if any of them ever fail, so during the resolution, the resolution algorithm is I get a hard yes or a hard no or a maybe. When I pick a guy, if I get a hard a no, it's because I have a conflict directly on types. Somebody's got a struct, somebody needs a function, a struct will never become a function, you're dead. So I throw those out of my list of choices and I never look again. So I shrink my set of choices every time I go through there. A hard yes means there are no leaves which can expand. So maybes come about from leaves, which maybe this will expand and become the thing I'm looking for later. So if I have a hard yes, it means there were no leaves in the choices. And I matched you item by item through all cycles and through all tree recursions. And because it's Hindley-Milner and there's an efficiency hack that says about unioning fine, usually those things immediately unify straight up to the top level guy in constant time. And so it's actually a constant time check. The hard yes is generally a constant time yes. Maybe it goes one layer in, declares a yes, then it becomes unified. Now it's always a hard yes. As soon as I'm a hard yes, I toss the other guys, everyone else who's not a maybe out. If I get a second hard yes from a maybe, then I have an error and I report that as unresolved. I got two choices that are both consistent. If I have maybe
a teach step, you have to have an answer. Can you get another maybe from a maybe?
Yeah, I can look at a maybe, it can stay a maybe. I don't get another maybe. Instead, the one maybe I got didn't resolve.
So you
I
have
need
to
do
wait.
something else on a maybe.
It has to come back at some point when you have more information.
Yeah. So I throw the maybes off to the side. I do other things. Then I come back around and look at the maybes again. If the maybes have resolved, I made some progress. And I keep repeating because my maybe pile got smaller. If I ever run through all the maybes and none of them resolved, I made no progress, I'm dead. This algorithm I've got incremental in AA already. So it's size.
Certainly what I do with Sudoku.
I'm sorry?
I said that's certainly what I do with a Sudoku.
Yes. Once I visited the maybes, I don't visit them again until I visited all other maybes and everything else. Everything else is incrementalized anyhow. So if they're all done the first time, they're all zero cost. Then I go revisit a maybe. If none of the maybes made progress, I'm dead. If a maybe made progress, I go visit everyone else before I go visit people again. So it's might be quadratic in the size of the maybes if I have a really bad visitation order, but I think it's actually going to be just linear, or you're going to fail. If you're going to fail, you might go a long time linear failing, but I guess you could go a long time and succeed. Keep making incremental progress on maybes. So I don't think it goes exponential on me because I demand somebody go first. Your exponential in my case would be, I would look at the set of unresolved, all of them at once, and start working the quadratic combination, exponential combination of choices. Pick one from this guy, and pick one for that guy, and pick one for that guy. Did it work? No, try again. Pick. That's exponential. Oh, that's not what I'm doing.
Okay,
all right. Are we done here? Can I?
There was just
I
one
just keep
last
thinking
question.
of the basic example of.
Well, Aaron, you're on the card. Go ask, but then Haven, you can ask also. So go, Aaron.
When I want to write, making sure that I can write things that look like this dynamic dispatch, but I guarantee resolve in compile time. How do I know that there's not a dynamic dispatch thing going on when I use the underscores? Or do I know that inherently when I use the underscores? It's going to figure it out.
The underscores turn into a constant field offset, an extra load of a constant value. So any field.
So at the end of the day, it's just as efficient as if I already knew when I put that string there for that field offset.
It's one extra load. But then also, if there was a function behind it, that function did not get inlined. So in this example here, if I make myself resolvable by getting rid of one of the guys and it's resolvable, this will turn into constant. This one will just turn into constants. It'll be direct fields, x.a, x.b in all the right places, and that'll fold up however that folds up. In the ugly factorial case here, this one, let me recenter it. This one says n.mul, that's a normal field load. This will be a normal field load with an offset based on we got past the hidden extra argument passed into factorial. Now I have a multiply operator that's either doing int times int or float times float or matrix times matrix or whatever the multiply operator is. And I call it. So you didn't get an inline primitive integer multiply. Now, having said that, the table descriptor for the virtual fields that passed into factorial blatantly, obviously demonstrates that specialization will clean it out. It's an inspection of a table of a bunch of constants. And it pretty clearly I can split the table in half, one for ints, one for floats. And on the int side, it's all ints. On the float side, it's all floats. Oh, I probably want to specialize this guy. Make 2 copies of fact, one that takes the left half table, one that takes the right half table, and then do the normal optimization. They'll all turn into constants at the base, and then they'll all optimize away and become.
And then you just write them a special rule that's like, if table size is less than 4, specialize. If it's more than 4,
yeah,
don't.
right. The table has a size and
Pick
it
a
has
magic number.
the member fields. And if I can see consistent member fields and I can see a small size, it probably makes sense to clone the code and hand you the fixed half of the table you get.
I like it.
Okay. Yeah, me too. It worked out in the end. Haven. And then Levi has a question too.
Yeah, actually my question was about, there was a mention of a Miller's algorithm again and again. I want to know
Hindley-Milner. You need to go find Hindley-Milner on Wikipedia. Let me go put that link in the doc. Let me stop sharing. Let me go find the doc. Somebody put a Hindley-Milner link in. No one did because the demo went forever. Let me go find Hindley-Milner. It's a standard algorithm for, oh, don't give me ad block, but I'm not sharing. Give me, yes, wiki. It's a strong normal typing algorithm that has been used generally with a lot of cool extensions for typing folks. There you go. Somebody got it already for a billion years.
Got it. Are there any other recommended reads other than the Wikipedia link? Like, is there a talk on it or a talk?
Once you can spell the name, you go Google. It's taught as a first, second, or third year course in every university on computer science on the planet. And you'll find an infinite number of resources. So
Carnegie Mellon, the CMU course is the one I like.
Oh, there you go.
Carnegie Mellon. Sure, I'll search on that. Thanks.
Yeah, no problem. Levo.
So I thought of this while you're using Emacs.
Yeah.
So I don't want a terminal in my text editor, but I think I would want to render the results of a couple of scripts. So what do I need to support? Because I know that some scripts expect you to be able to display color, but I don't know what else after that, or other than that.
You want to display a script or execute a script in a window?
Yeah, so if I have a shortcut key in my text editor that executes a bash script or some kind of program, what do I need to display as like a read-only window?
Well, okay, so Emacs has like 3 of them, according to which one. One of them is you edit the command line inside of Emacs, and then you hand it off to whichever your shell is. One of them is you edit the command line using the shell's built-in editor, like Bash has a built-in line editor. And one of them is eShell is ain't no shell. It's an Emacs Lisp shell. It's no normal shell, which does other weird things like he can intercept large outputs from redirected files and put them in buffers directly.
I don't want to take any dependency. I was just like wondering about the rendering side.
I'm pointing out a couple choices of how you decide how you want to do it. If you throw things in a buffer that is just the normal buffer, an Emacs normal buffer, it color codes fine. And then you can, edit it, controlled state, you can declare it read-only, view it, search it. The big one for me is obviously you dump your search. Hey, I do a less or a more, I get a giant ass thing in a buffer, I can search it with Emacs.
Yeah, I still working on some search. I haven't touched that thanks to rendering.
Okay.
The font rendering was you don't get the answers you expect to get.
I saw your issues with font rendering going by. That was pretty wild. Yes. So anyhow, once I got in a buffer in Emacs also doubles up as like an awk wannabe. It's actually a pretty powerful awk wannabe. So I often take things out of dumped buffers from shell scripts and put them off into a side buffer and begin folding, stabling, and mutilating them using Emacs as an awk replacement.
Yeah, I definitely wanted to support copy pasting from the results.
Yeah, no, that's a really handy thing to just run a function and throw it in the buffer. In fact, you didn't see it, but if I run compile, he runs make in a buffer. It's a read-only buffer. Color code's fine. I can search it and do whatever I want. I run grep, it goes in a buffer. I run a bunch of things that go into buffers. The grep buffer is smart enough to grab the file name links that he added flags, make grep barf, so you can search and fool around in the grep buffer, but if you hit enter on a line, it jumps to the source text at the point where the grep got a hit.
Does make and other tools become syntax highlighted? Because I didn't even think about that.
He allows ASCII character codings for color if such tools spit them out. Many compilers will spit out color-coded error messages. Not all of them, not all the time, but it happens.
Okay, I see. Yeah.
And then if he sees a compiler error message as part of the output, Emacs will highlight that, color-code it. And then if you get on that line in the compile buffer and hit enter, it'll take you to the error message place. And in fact, I've set up so that the default behavior is the first error I just go to. So I hit my one button for make, and the first error pops up above it, and below it is a description of the error from the thing, and it's generally instantaneous. And it's
I
pretty
should
common
definitely do
Emacs
that.
thing. Sorry?
I was going to make that 2 buttons, but I should make that 1. Yeah.
Well, it's optional. I took the option of making it 1, and then there's a button to go to the next error and the next error and the next error and whatever. It's the usual thing.
Yeah. See, VS Code, well, maybe it does support it, but I haven't found a VS Code thing to do to like cycle through all the errors.
Yeah.
So I
Really?
definitely doing that.
It's like the very first thing any IDE should ever do is cycle through the errors. And once you can edit and once you can view and run, now you want to cycle through your errors. Yeah, fine.
And click links on errors to get it to take you to the code.
Exactly. Yes, exactly. It's
Well, it does the
like
link, but not the keyboard shortcut for cycling.
And
maybe there is, but I gotta find it.
cycling. See, and if you're going to be doing all these keyboard shortcuts, you should just look at Emacs as the king of keyboard shortcuts. There was no mouse. It was only keyboard shortcuts.
Yeah, it's just so many of them, and
that's okay. He has a mouse.
Was ignored.
Fine, fine. All right, I'm going to declare victory here. Yeah. I got Aaron to at least say it looks good. That was made me happy.
No, I like it. I was a little skeptical. I don't know, 2 years ago when we were still on this underscore thing.
Oh, you should have been. I was thinking this looked easy, and then it wasn't, and then it was, and then it wasn't, then it was, and then it wasn't, and then 6 months later, oh, I think I have a solid answer finally.
So does that mean you're close to REPL so we can start writing a standard library and seeing where the pain points are?
AA, actually. I have to go take all this and make it go into A. So the output of this was I have an SEK machine and a typing algorithm that works. Now I have to take the typing algorithm at least back over to the AA side and clean it up. The actual
so it sounds like one of the big differences between this language and real AA is in real AA, people add assertions.
Oh, yeah. Yes.
This type is this name and that type is this name. So they better be the same as each other.
Right. There is a thing there. There's a lot of syntax niceties in AA that aren't in the SEK machine, which is basically a pure lambda calculus. If you go look at how I parse, it's just first character, open paren, @ must be one of the other 5 choices. That's it. Parser's done. It's a really trivial parser. AA has a definitely more complicated parser.
So it's going to take some time to get the stuff back into AA.
Yeah, it's not just the parser, it's the typing things I have to take it back to AA. I'll need to add an extra hidden argument everywhere. I looked at a bunch of stuff we did at Simple, and it cleaned up a bunch of things I have in AA. Like there's some things I'll probably change more stuff here. There's a bigger bite to be done. See if I can simplify a bunch of the core AA structures, which have just accreted shit over the last 5 years.
Yeah, Simple's a real nice thinking tool.
Yeah, right, exactly. So there's some stuff that, it won't do what I want, everything, the AA, so it's too simple. But the cleanup...
Has Simple convinced you that there's any feature of AA you can remove and just write as part of the standard library?
Yeah, well, that's where that's the kind of thing I'm looking at. The things I'm going to pull out are like a bunch of the iterators can be simplified. A bunch of the printing can be moved off to the side, go to the core guy. The peepholes during parse time have two versions. I took the complicated version. I like much better the simple version, so I'm probably going to unwind that decision as well. And in the result, I think the parse will be a lot easier. There'll be a bottom-up loop that will be work list based. That'll be a little more complicated, and there'll be and then the combo top down.
Why is the parser work list rather than just a recursive descent?
For the peepholes.
I see.
Because
you want to clean stuff up as soon as possible.
Yes, but I cleaned up more than I needed to as soon as possible. Because really the goal of the peepholes and the parser is to make the parser of large programs run faster because you delete shit earlier, but not to be optimally nitpicky. That in turn makes the parser have delicate invariance. That AA's invariance, sorry, simples invariance, while they're maybe sound delicate, they're definitely simpler than AA's invariance. So I'm going to go to the simple invariance.
Does your parser put comments in the parse tree?
Well, I could. I don't. I track the line number offset directly. I keep the source around, so error messages directly refer to the source. That's not an issue. But I could keep the parse info in there. It's not an issue.
Go talked about that a lot. Of they wanted to do programmatic refactors of things.
Yeah.
And if you want to do something like put all of the functions in this file in alphabetical order.
Right.
It's really nice if the block comments move with the functions.
Right. So, of course, you have anonymous functions. So, alphabetically sorting an anonymous function is difficult.
Sure.
But you have named functions too. And in fact, one of my debug hooks in there now is to say, if I've assigned a function to a name as a final field name, I'll go ahead and associate that name. Just as
to some extent, your functions, right, you would not have sort your functions, you would have sort all of your fields in your struct.
Yeah, you could do that, right, yeah.
Which would be the equivalent transform here.
Yeah.
And you still want to have clearly expressed as part of your language something like, if I say // immediately above the name of a function, is that associated with the function below it or the function above it?
Oh, I see. You're saying start doing things where I do comments and associate them some way or another.
Right.
Yeah, fine.
So like one of the things Russ did that I thought was interesting was if I start a comment with 3 slashes, it's a doc comment that is relevant to the thing below it. Whatever the next symbol is that's referenced, this is a block comment that is referenced to that. And when you build the docs for that thing, bring me along as a doc string because I've got 3 slashes.
Yeah, okay. That sounds...
If I say // exclamation point, that says, no, this isn't about the next symbol. This is about whatever block I'm in. So if I am // exclamation point, that block comment string should show up on the class, not on the function that it is above.
And then do you have a / to closing / or / to end of line?
I don't think so. I think you have to use line comments to get this particular magic. You can't use block.
Right. That's not a terrible answer. Either way.
But I thought it was an interesting idea to say, no, we are going to explicitly, as part of our syntax, say, what is this comment about? And if someone is programmatically transforming the code because they're like running a Java doc-like thing that wants to build a PDF that describes how to use your thing, it knows which comments go with which things. But to do that, you A, need comments in your parse tree, and B, need to be explicit about what kinds of things your comments are getting attached to.
Right. Of course, I don't build a tree. Right. And I can grab comments as I go and throw them on a node. That's fine.
But how do you plan?
Right. If your last step instead of code generation is PDF generation, same diff.
Yeah.
How then do you plan to expose for programmatical rewriting, if you will, if you don't have trees?
Oh, it's whatever. I mean, who is the consumer of such a thing? If there's a language server.
So at the scheme of
you
it,
can build a binary because something does block layout. When you're done, you can. Okay.
Sorry, Theodore. Yeah, you're in a car. There's some delay there or something. Yeah, Theodore was in the middle of still talking. So go, Theodore.
No problem. Let me.
Blow your stack. Yes.
Yeah. About the tree here. So as I remember, you're parsing directly something like an a CF node form.
Yeah.
So you don't have a tree like a syntax tree.
Right.
So how would you admit rewriting a program if you don't have a syntax tree? So you have to manipulate directly the CF node tree.
Oh yeah, right. You manipulate the CF nodes. Yeah. That's what I've been doing in the past. I'll say all my life, but for a very long time.
So of course you're manipulating the program like a syntax tree, of course, but wouldn't that impose a burden on the users?
No. I'm not manipulating the program like a syntax tree. I'm manipulating it like a sea of nodes.
Okay, fine, but that imposes the users to know how to manipulate the sea of nodes.
So here's the deal. After I get into sea of nodes, I ain't got no syntax tree like thing but anymore. So there is no way to manipulate it. That behavior is gone. I can fake a tree, and then you can manipulate the faked tree. But there's always inefficiencies when you're doing this. I go to a form that is a denser and richer format than a tree. I don't need the information that's contained in a tree, and so I lose it.
So yeah, you can recreate it. Yeah, of course, sure. But
I can sometimes create it. Just to be clear, there are structures you can get in the sea of nodes that have no tree, like there is no tree mapping for them. In any irreducible loops, which AA can totally.
Yeah, but because they do not directly map to the syntax. There is some other meaning in the node.
Right. So for people who do programmatic restructuring, if they're starting from the place that they have a tool that understands a tree and they want to keep using a tree, the best that can be done is take AA and fake your way back to a tree.
Yeah, because
if they're starting from. Well, go ahead. I'm interrupting you.
Yeah, no problem. Without a language, as I encounter, so the problem was, let's say in Scala, that you tie too closely to the internal structure of the compiler of the tree. So in Scala tree, you have something like an API to manipulate the trees. It's not exactly the trees with the. So you will kind of need something like that, because in all of the languages I see, if you tie the meta program, the syntax manipulation of a program exactly as in the syntax tree in your compiler, then you're fixing. So you fix that manipulation of the program to the syntax tree, and that's always not what you want. You want something like an API that is separate and it's stable.
Okay, so I'm not there. I'm not at that point yet.
Yeah.
But the API I have right now would be the sea of nodes itself, which that's still undergoing rapid mutation, as for instance what happened today. So,
but I imagine if you are willing to manipulate the program, so you're willing to pay the cost to construct the syntax like tree API to manipulate.
When we get to the point where I have an execution engine and a well-typed language, then it gets to the point of, hey, how does an IDE work with it? And what do I want to support an IDE with? And that's a language server. And how does a language server interact with your language?
Because we started from with Aaron's comment to manipulate the programs programmatically. So you manipulate the source programmatically.
Yeah. Right. I'm saying I'm not there yet. That's a future work.
Yeah.
It's not that it can't ever be done. It's just that it's not happening today.
Yeah. We're just discussing. So.
And Aaron, did you have another question? Comment? No, we might have lost Aaron. He's driving.
No, I think this was good.
Okay.
Particularly since I came in so late.
Yeah, you missed the big demo you have to watch. All right. Anyone else? I'm going to declare victory. All right. Till next week. Bye.
Bye. Bye.